The next force we want to look at is drag. Whenever an object moves through a fluid, and by a fluid we mean either a liquid or a gas, so air is a fluid and water is a fluid. So whenever an object moves through a fluid, it will experience some type of resistance to that motion. This resistance, which in the case of the air is called air resistance, is also referred to as drag. So the drag that an object experiences as it moves through a fluid normally depends on its shape and on how fast it's moving. So you've all probably at some point in time stuck your hand outside the window of a car, and you know that the faster the car moves, the greater is that air resistance that you feel. Drag is the force that accounts for the fact that a leaf falls through the air much more slowly than, say, a rock. Of course, if we were able to conduct an experiment in which we removed all the air, then the leaf and the rock would fall at the same rate. For the most part in this course, in the problems that you are given, drag will be negligible. So unless the problem explicitly says that you need to consider the drag on the object as it moves, you can assume the drag to be negligible. When we do work with drag, the symbol we'll use will be a capital D. A very important property of drag that you need to remember is that drag, like friction, always opposes motion. So if an object is moving to the right, if it's moving to the right through some medium, the drag will act to the left. If an object is moving downward, the drag will act upward. Okay, so let's look at another force. We're going to use the word thrust to refer to the force that propels a jet forward or a rocket. We don't have a special symbol for this, so we'll simply call it F and then thrust. If in a particular problem you find you don't want to write all of this out, you can simply just use the symbol F and just make sure in the problem just make sure in your solution you indicate that this is referring to the thrust. So here we have the list of forces we'll be dealing with in this course. Note that this is the only long distance force, and these are all referred to as contact forces. Some sort of contact has to take place. Now bear in mind that deep down on an atomic level, all these forces are not really different, but we won't be dealing with these phenomena from an atomic level. We'll be dealing with them at the macroscopic level. You know, when you deal with a rope, you don't try and imagine the atoms, you just have a rope. So when you're dealing with these forces from, you know, the normal everyday point of view, this classification serves us well. But just remember that it is a classification, and in a sense a fairly arbitrary classification. But I don't want to give you the impression that there's anything trivial about this. This classification will serve us well. So all of these forces are contact forces. In the case of thrust, for example, it's the gases that are expelled by, say, the rocket that push the rocket forward. So in a rocket, what you have really is a controlled explosion. The gases are expanding and they push the rocket forward. So there's contact. And of course, for friction, there has to be contact between the surfaces. You know, normal force, there's one surface pressing against the other. Tension, there is some kind of rope or cable attached to something. And in the case of a spring, the spring also needs to be touching something in order to exert that force. Okay, so now that we have a list of forces, we will look at three very important laws that govern all these forces. Pay careful attention to these forces. Very often I find that students, when they're given a problem to solve, forget to realize that a force is something concrete, in the sense that we can always identify it as being one of these, at least in this course. So we won't be dealing with, say, electromagnetic forces or nuclear forces in this course. So whenever you're given a problem and you find that you need to identify the forces, well, your selection has to come from this list. So don't go inventing strange forces that are non-existent. You need to have this list of forces in your head and make sure that the force you identify is one of these. Okay, so let's look at Newton's laws now.